All right, so 10.1 is the rectangular system. And I already have notes on this, so I'm going to refer back to those. So this is for myself. All right. So you're going to be graphing on the Cartesian coordinate plane. Where you have your two axes, you have your horizontal axis and your vertical axis. Your horizontal axis is your x-axis. Your vertical axis is your y-axis. Where they intersect is your origin. It has the coordinates of 0, 0. You have four quadrants going counterclockwise. Quadrant 1, you make two positive moves to get into quadrant 1. Quadrant 2, a negative move and then a positive move. Quadrant 3, two negative moves. Quadrant 4, you go positive and then negative. And then mention in reference to your origin, everything to the right of your origin is positive, everything to the left of your origin is negative. Everything above your origin is positive, everything below your origin is negative. So that's what I meant by your positive moves versus negative moves. We will graph at what we call ordered pairs because the order matters. So x first and then y. So you can think about x comes first in your alphabet, then y. In other words, you have to, or you can think about you would run and then jump, or maybe walk, then go down the elevator. But you always make your horizontal move first, then your vertical move. Your x move or your x-axis first, then your y-axis. Well, all right, so putting our graphing to work. If we have just these points, random points, and we want to graph, if I look at 2, 5, you always start at your origin, and I would go to the right 2, up 5. So I think I'm just right here. So that's 2, 5, and that puts me in quadrant 1. Next one, -1, -3. Start at your origin. Go to the left one, down 3. See something? Yep, Q3. Supposed to be right down here. And then -4, 2. So start your origin. Go to the left 4, up 2. Did somebody else just answer? Yep, puts us in Q2. And then 1, -5. Go to the right one, down 5. Oh, yep, you got it. Q4. Any questions on those first 4 points? All right. So now the next 2, you would go to the right 3, but then nowhere for X. I mean, nowhere for Y, excuse me. So that's not in either one of the quadrants. That just puts you on the X-axis. And then for that last one, you would not move right or left, but then go up 3. And that will put you on the Y-axis. All right. Any questions with graphing so far? All right. So solutions for an equation, for an equation is an ordered pair. Ordered pair is a solution for an equation if the equation is true after the ordered pair is plugged in or substituted in. So if you have 4x minus 3y equal to -2, and they ask you if 1, 2 is a solution, then what you would do is plug in 1, 2 accordingly. And remember, in your ordered pair, assume you know that the first value is x and the second value is y, because that's what will always be as far as ordered pairs are concerned. First value is x, second value is y. So you plug in 1, that's 1 times 4. Plug in 2, that's 3 times 6. 4 minus 6 is -2. And so that would be a solution. And there are infinitely many solutions to a linear equation. That's what the line represents, all of the ordered pairs that are solutions for your equation. And we have talked about a graph here, but a line that we graph for that equation represents all of the solutions that are for that equation. So, oh, here I'm just doing that again. Here I had y with a 3x minus 5, and we had two ordered pairs, and we want to see if there were solutions. So 2, 3, plug it in, 2 for x, 3 for y. That's this one right here, ordered pair 2, 3. So 3 equal to 6 minus 5. 6 minus 5 is 1, so it ended up not working. And then right here, we plugged in the ordered pair of 3, 4. 3 for x, 4 for y. And our right equation was y equal to 3x minus 5. So 4 for y, then 3 times 3 is 9, minus 5 is 4, and that one worked out. I should have left that. All right, so graphing your linear equations, you have 3 methods that you can use in order to do so. Creating an XY chart is 10.1. In 10.2, they talk about intercepts and they talk about slopes. All right, so let's look at the first method today. All right, let me erase this stuff. What just happened? Okay. All right, so let's do this first method, creating an XY chart. So if I have the equation of y equal to 2x plus 1, in order to create my XY chart, I'm going to have to choose some values for x to plug in. So it doesn't matter what you choose, and I'll show you why in a second. But just remember, whatever you choose, you're going to have to graph it. All right. So you plug in. So I chose -1, 0, and 1. You may not want to choose a negative. You might want to choose 1, 2, 3. Choose whatever you like. Like I said, whatever you choose, just remember that you have to graph it and you have to calculate with it. So make sure you choose something that's simple. and you plug them in. So that's 2 times -1 plus 1. So you plug it in -1 for x to find the corresponding y value. 2 times -1 is -2 plus 1. And that'll be -1. So it just so happens that in this equation, or this example, when x is -1, y is -1, plug in 0. 2 times 0 is 0. 0 plus 1 is 1. Plug in +1. 2 times 1 is 2. Plus 1 is 3. So before we use that information to graph, any questions? All right. All right, so we'll graph those 3 points. Start at your origin, go to the left 1, down 1. Start at your origin, nowhere for x but up 1. Then go back to your origin, go to the right 1, up 3. And that'll be our line. So like I said, it doesn't matter what we choose. Notice I got arrows going at the end of my line going in each direction. So if I chose positive 20, 20 would be somewhere up here, up to the right. And then that will give me a point that's way up here that will still connect to this line. Same thing with -100. It will be way over to the left, but it will give me a value that's a lot further down that will still connect with the line. So just have to remember that whatever you choose, you have to graph. Questions? Any questions? All right, so next one, we have -3, y equal to -3/5 x plus 2. So here we want to be strategic in what we choose for our x values because we have a fraction involved. So what we want to choose are multiples of the denominator. All right, so 5, 10, 15, 20, anything that 5 can divide it to easily is what we want to choose. All right, hit the wrong button. So we're going to choose multiples of the denominator. denominator. So if that denominator was 7, we would choose things like 7, 14, 21. You can choose -7. If it was 11, choose 11, 22, 33, and so on. You want to choose multiples of your denominator. So I chose -5, 0, and 5, keeping the same pattern of -1, 0, and 1. And so we'll plug them in. And the reason why you're choosing those values is because we want to have something that will cancel out the fact that we have a fraction. We don't want to have to graph a fraction. So that's -3/5 times -5 plus 2. You can go ahead and cancel, or if you want to just multiply it out, you can. That'll be a positive 15 over 5 plus 2. 15 over 5 is 3 plus 2 and 5. Plug in 0. 3/5 times 0 is 0. So 0 plus 2 is 2. Last one, plug in 5. So -3 times 5 is -15 over 5 plus 2. That's -3 plus 2, which is -1. All right, any questions before we graph? All right, so -5, 5, I'll go to my origin, go to the left 5, up 5, go back to my origin, nowhere for x, but up 2, then to the right 5, down 1. Any questions? All right, let's see. What was that class? All right, so and this notice for me, not for you guys. I'm about to go to another page, finish off this chapter. 4. All right, so the last thing in this section is functions. So start off talking about a function by actually defining what a relation is. A relation is just any set of ordered pairs. So an example of that is 1, 2, 3, 4, 5, 6. Your domain is a set of all your first components of your ordered pairs. So 1, 3, 5. Your range is a set of all of your second components of your ordered pairs. And that is 2, 4, 6. All right. So the differences between your domain and range. As we mentioned, your domain is your first components. Your range will be your second components. Normally your domain is associated with your x values, your range, your y values. Domain is your input, range is your output. Domain will be your independent variable. Your range will depend on your domain. And also your domain is your horizontal axis. Your range will be your vertical axis. All right, so the definition of a function is a relation in which the elements from the domain corresponds to exactly one element in the range. All right, of course, if you're still copying and I move up, let me know so I can go back down. All right, so here, determine whether each relation is a function. So we have 1, 6, 2, 6, 3, 8, and 4, 9. So what we can do is set up a mapping, a simple mapping of which numbers go to which numbers in your domain go to which numbers in your range. So remember the definition of your function. Each function or each element in your domain has to go to one element in your range. It didn't say that they couldn't go to the same element. It just says that it has to go to one. So you will look at each one of your elements in your domain individually to see if they go to one value in your range. So we know 1 goes to 6, 2 goes to 6, 3 goes to 8, 4 goes to 9. So once again, look at them individually. Does the element, does number 1 go to exactly one element in your range? Yes. Does 2 go to exactly one element? Yes. Now it may go to the same one that 1 goes to, but it's still going to, you're looking at them individually, that 2 is only going to one element in your range. 3 is going to one element, 4 is going to one element. If you can say yes to all of your elements in your domain, then the answer is yes, it is a function. Questions on that before we look at B? That was something somebody else asked. So here we have 6, 1, 6, 2, 8, 3, 9, 4. And we want to know, is this a function? So we do the same mapping. Set up your elements in your domain, set up your elements in your range. And we see 6 goes to 1, 6 goes to 2, 8 goes to, hold on, 8 goes to 3, and 9 goes to 4. So you go through each element individually like you did last time. Ask yourself, does the element in your domain goes to exactly one element in your range? And the first one we look at, number 6, the answer is no, because 6 goes to 1 and 2. And all we need is one of them to be no in order for the whole thing to not be a function. So no. All right. So having repeated values in your domain is a problem if you're trying to establish whether you have a function or not. That means it's not a function. Because remember, we had repeated values in your range before. Go back, repeated values in our range, and that was a function, so that's okay. But having repeated values in your domain ended up not being a function. All right, so that's just what I said here. There's different ways of looking at whether something is a function or not. There can be a repeated value in the range, but no value can repeat in the domain. Or the range can go to more than one value, but the domain can only go to one value. Last thing in this section, might be able to make it happen. Let's see. All right, so the last thing in this section, we don't look like we're going to finish it, but at least we get started. Start here with on next class, function notation, y equal to f of x. So it's just saying that wherever you see y, you can plug in f of x, and that will be considered function notation. And so they will expect you to know that if f of x is substituted in for y, then you know it's in function notation. If they were to switch it back, put a y there, you know it's not, function notation. All it does is give you the opportunity to substitute in a value or use symbolisms to give directions. So if they tell you to find f of 5, then that means that where x is, you're going to put a 5 in your function. Your function had to be defined first before you can do this problem. So you can't just say find f of 5 and they never gave you what f of x was. So if you want to find f of 5, you'll plug in 5 into your equation and then just calculate. So that's 2 times 5 plus 1, which is 10. 10 plus 1 is 11. So f of 5 is equal to 11. Also, the information that they give, when you see that, is that x was 5, 11 was y. So that's your ordered pair for that. Remember, your domain is your input, your x is your input, your range is your output. So we plugged in 5, got out x. Plugged in 5, got out 11. So you plug in your x, you get out your y. And that is pretty much it for that section. Next class, if you think about it, I can do one more example, but still just doing that. You're plugging in the values. And see, the lecture will go on YouTube. Yep, I will not plug in. I'll create the lecture. I'll probably be able to find time to do it today, but at some point before the week is out, and then shoot you guys the link. Yep. Because it was, yep, I did record it, so we all good. Yep, no problem. So with that being said, it's 8:49. I'll go ahead and let you guys go. Like I said, next class we will review. So if you have questions, bring them next class. I will not do anything new. So anything I finish out of 10.1, if I have anything left, like I said, if I do that one more example out of 10.1, I'll do that on Monday, and then get rolling with 10.2. But outside of that, you guys have a good Wednesday, and I will see you on Friday. All right.